Alrighty, y'all, Mr. Montana here. We are going to go ahead and get started on parallel and perpendicular lines notes. So we're going to start right here in this top box. And the first thing that we need to do is we need to identify these different types of forms of equations that we have here. In the first box, we have y equals mx plus b, and you should know that this is slope-intercept form. The second one is going to be your point slope form. And then the last one is going to be standard form. All right. And so for slope-intercept form, you have y equals mx plus b, where m is going to represent your slope, b is going to represent your y-intercept. In point slope form, you have y minus y1 equals m times x minus x1. And you know that x1 and y1 are going to be a point on the line. That will always be given. And then m is going to represent your slope. And then for standard form, a, b, and c are all coefficients, and x and y are your variables. All right, looking at the questions down here, focusing on slope-intercept form. So the first thing that question 1 says is it says that we have a slope of half and y-intercept of 0, -3. And so the first thing we want to do is we need to go ahead and write our equation using the given information. So we should know that our formula is going to be y equals mx plus b. You should understand that your y and x variables are always going to stay the same. It says our slope is half, and if we look at our table above, we know that m represents the slope. And so we can just plug in our half right here. And so now we have half x plus b. And so then we're going to go ahead and just put plus, and then our y-intercept, which is a -3. This can then be simplified to be y equals half x minus 3. And that would be my equation right there. So we were given our y, or our slope. We were given our y-intercept, and then our equation was, again, half x minus 3. Now, looking from a tabular representation on question 2, what we need to do first is we need to be able to identify what our slope is from a table, and that's when we're going to have to use our slope formula. And our slope formula is going to be y2 minus y1 over x2 minus x1. So, always label your table. We're going to have x1, x2, y1, y2. So then I plug in, I'll get 2 minus 5 over -2 minus 3. When we have subtracting a negative, we chop to make it a plus. And so 2 minus 5 is going to be -3. -2 plus 3 is going to be 1. So I now know that my slope is going to be -3. And then now we have to look at our table. So our y-intercept is always going to occur when we have x equaling 0. So x equals 0 right here, and our y value is -4. So in other words, our y-intercept occurs at -4. So now we can go ahead and use our formula. We're going to get y equals m, which is -3. We keep our x, plus -4, which is really just going to be -4. All right, moving to question 3. On question 3, we're given a linear representation, and the most important thing that we need to do here, y'all, is we need to find 2 good points so we can find slope. So I like to personally go with ones that touch the axes because those are going to be very, very easy points. When looking at a graph, all we need to do is rise over run. So what we're going to do is we're going to go 1, 2, down 2, so -2, and then over 1, 2, 3. So my slope is going to be -2 over 3, and so I'll write this in this box down here. And then now I need to look, where does it touch my y-axis? So my y-axis is the one that's labeled here. I'm going to go ahead and color it pink. And our point happens right here. And that is at -2. So then now, y'all, we can go and fill in our formula. Y equals mx plus b. So y equals -2/3 x minus 2. Moving over to question 4. Again, we are given a graphical representation. The most important thing that you see here is we have a vertical line. And so what we need to recall is we need to recall our Hoy and Vux. So we have a vertical line. So we're going to go ahead and use Vux. So vertical, undefined, and x equals. All right, so that tells me right there that my equation has to be in x equals form. So I'm going to go ahead and write that, x equals. This middle part tells me my slope is undefined, so I can go ahead and write u in d. And we can just look at this graph, and there is nowhere right here where this graph is going to touch that teal line that I'm creating. So that's going to be not happening, right? But the one thing we do know is that this graph happens at 2. And so our simple equation would just be x equals 2. Alrighty, now focusing on the back page, we have question 5. It says to write an equation in point-slope form. So point-slope form is this equation that is given to us in our box up here that I just highlighted in teal. And so we're going to go ahead and work with that equation. The thing that we need to understand is that the things that are going to be replaced are going to be this y1, the m, and an x1. Those are the only things that will be replaced in this equation. So writing this out, we need to understand that our point is going to be x1, y1, and our slope is going to be 4 because it's given to us. So I like to write out my equation just the way it's given to us in its original form. And then what I like to do is I like to take a highlighter and I'll highlight the things that I'm going to replace. So I would highlight the y1, the m, and the x1. And then now I can go through and I'm going to drop down everything. So y minus equal sign, a parenthesis at x minus parenthesis. So everything that's going to stay exactly the same, I'm going to go ahead and write out. And so then now from the information that's given above, I can go ahead and pull out my different things. I know that y1 is going to be a 2. I know that my m is 4. And my x1 is going to be a 1. And so then at this point, y'all, you may have to solve for y using distributive property and then carrying the 2 over. And I will do that really quickly for y'all just so y'all have an example in your notes. So we would distribute the 4 and we would get y minus 2 equals 4x minus 4. Add 2 to both sides. And we would be finally left with y equals 4x minus 2 as your final equation in slope-intercept form, right? But since this equation just wanted point-slope form, we are fine to just leave it right here at this section that I just highlighted in blue. All right, moving to question 6. It says point 2 comma -3 and has the same slope as y equals -5x minus 4. The first thing I would do is I would try and pull out the slope from the equation that's given to us. So if you notice, it is in y equals mx plus b form. And we know that m stands for slope. So I need to look at my m right here, which is going to be -5. So now I have everything. I'm going to go ahead and start plugging into this formula. Again, I'm going to write it out in its original form. And then again, go back in with my highlighter, highlight the things that I can change, and then now start plugging in. So, now drop down. So I'll bring this y minus equal sign, parenthesis, x minus, close parenthesis. And then I'll start plugging in. I know that my y1 is going to be negative 3. And I know that my m is negative 5. My x is going to, or my x1 is going to be a 2. And then right there, y'all, that is my final answer. I can go ahead and leave my answer like that because it wants it in point slope form. Moving on to question 7, this is where we get into the new material, and we're going to be writing parallel or perpendicular equations. All right, so this question 7 says to write an equation of a line in slope-intercept form. So that's going to be our key right here. It wants this in slope-intercept form that passes through the point 6, 0 and is parallel to the line y equals negative 2x plus 2. So from last class, you should have learned that when we have parallel, you need to think same slope. And from this lesson, you should be able to pick up that slope-intercept form is y equals mx plus b. So now we need to combine the two things. We also need to be able to pull out our slope out of this equation that was given here at the very end. Again, it's the same method as the previous question. So you should be able to pull out that m equals negative 2. So now we need to apply this thing. It wants it in slope-intercept form. I don't know what my b is. I don't know anything else about this equation except for the slope and a point. So at that point, you need to think about what formula can I use? Oh, well, I have a point and I have slope, so I must use point slope form. And so what you're going to do is you're going to write out your equation. Y minus y1 equals mx minus x1. Again, going through with the highlighter on things I can replace, the y1, the m, and the x1. And then now what we're going to do is we're going to drop down everything that stays the same. So y minus equal sign, parenthesis, x, parenthesis, and a minus. Okay? And then fill in our new stuff. I have x1, y1 with my point. So I get y minus 0 equals m, which is negative 2, and x1 is 6. So this is going to be one of those equations where you're going to have to distribute and solve for y because it wants it in y equals. All right. And so this y minus 0, this minus 0 really does nothing, so I can go ahead and mark it out. So I'm left with y equals negative 2x, and then negative 2 times negative 6 is going to be positive 12. And so this right here will be my final equation. And just to verify that you did that correctly, check. Does this equation and the new equation have the same coefficient in front of the x? Yes. So we know that they're parallel, and we know for sure that they do go through that point. All right, moving on to question 8. Looking at question 8, it says to write an equation of a line in slope-intercept form that passes through point 0,5 and is perpendicular to the following equation. All right, so first things first, let's go ahead and think about what does perpendicular mean. Perpendicular is going to tell us that they have a negative reciprocal slope, or you may have heard opposite reciprocal. And guys, all that means is we're going to change the sign and we're going to flip it, okay? So we need to find our slope and identify our slope from this equation, but we are given the equation in standard form. All right, so this is in standard. There is a shortcut to figuring out how to find slope from a standard equation. What you have to do is you have to remember that this is ax plus by equals c. So in order to find the slope from a standard equation without having to solve for y, all you have to think of is that your slope is going to equal negative a over b. So I need to look at my a. My a is going to be a 4. So I'm going to keep this negative sign, put my 4, and then my b here, there's nothing there, but when nothing's there, we assume it's a 1. So therefore, my slope will be negative 4. So now I have my slope. Now I need to find the negative reciprocal of it. So that means I need to have my slope in a fraction, which I did right here. I need to flip it and also make it the opposite sign of what it is. So it's negative now, so I want it to become positive, and it was originally 4 over 1, so now I need to flip it to make it 1 over 4. So now this is going to be my new slope. And then with that information, we're able to label this point x1, y1, and then yet again plug in y minus y1 equals m times x minus x1. Again, go through with my highlighter, highlight the things that I can change, and then go ahead and drop down the stuff that doesn't. So y minus equal sign, parenthesis, x minus parenthesis. Good. And then now we are going to fill in. So I get a 5 here. My slope has to be 1/4, and then a 0 here. So we know that the 0 is really not going to matter. Let's go ahead and mark it out. We do still have to distribute here, so I get y minus 5 equals 1/4 x. I want this in point slope form, so I have to get y by itself. And so I will end up getting y equals 1/4 x plus 5 as my final equation. Alrighty, y'all. Have a good one.